Hi students, let's look at this question here, which was taken from the year 2020 IGCSE Specimen Paper 1 question 6. Let's see how we can do this proficiently, okay? So you are told to find the equation of normal to the curve y equals to 2x minus 1 over root x squared plus 5 at the point where x equals to 2. Give your answer in this form. I think this is a pretty typical question here. So the first thing is, let's try and understand what's going on. So let's say you have a given curve here. I'm not sure where x equals to 2. This is just for illustration, okay? So x equals to 2 is here. Now we know that this line here would be the tangent. Roughly this touch at the point, right? Now the question now is, how do you find the gradient here, which is the normal? I think this is roughly normal here. Okay, so this is m tangent, right? M tangent will be equals to dy dx when x is equals to 2. And this is actually the m normal here. Okay, this is m tangent. Okay, tangent. So, we know that to find the, in order for us to solve this properly, to find the equation of the line, we need a point and a gradient, right? Because y equals mx plus c, we need a gradient, which is m normal. In this case, is normal, and the point here. Okay, so actually you could just find the point first. So you find the point by substituting it in. So by when x equals to, what do you call it, 2, y is equals to 2 times 2 minus 1 over square root 2 squared plus 5 with 3 over square root 9, which is actually just 3. This is 1. Goodness, that's good. So now we're going to find the gradient of the normal by finding the tangent first, because dy dx, right? So dy dx, this is y equals to 2x. So this is y equals to 2x minus 1 over square root x squared plus 5. So square root x squared plus 5. What we need to do is use quotient rule. I prefer quotient rule. I would really recommend you to use quotient rule because there's a square, there's a root below, and this is the formula for quotient rule: v du dx minus u dv dx over v squared. Just remember, square the denominator, then the denominator multiply with just differentiate the top, then minus off, keep the top, differentiate the bottom, right? So yeah. So this part here, once you get it, this will be root x squared plus 5 squared, and v, which is x squared plus 5, du dx will just be 2 minus u, which is 2 x minus 1, dv dx, which is actually just half x squared plus 5 minus half 2x. Okay, maybe this is a bit too intense. Maybe I should slowly write down and color code it for you. In this case here, my u is actually 2x minus 1. So my du dx will just be 2. And my dv dx is, sorry, what am I doing? Sorry. I'm too used to this. My v will just be square root x squared plus 5, and this will just happen to be x squared plus 5 to the power of half. Just put the outer layer and inner layer here. So chain rule meaning I'm going to put v, this half, bring it down, so it's half x squared plus 5, half minus 1, which is negative half, and 2x. Okay, slowly, and you will get half x squared plus 5 minus half times 2x, which is what I got here. So let me just color code it nicely for you. This would be my v, this is my du dx minus v times u times dv dx. Okay, so that's how we do it. And the denominator will be squared, so it's v squared below, so that's pretty okay. Now once you've done that, just slowly express it. Oftentimes you realize that this part here where it requires some manipulation, students will struggle, but yeah, just press on. Any questions, just to let us know. We will try our best to help you as much as we can. So I'll just slowly do this part here. This will just be 1 over square root x squared plus 5. My goodness, times x. Okay, nearly having a casualty there. So this x here, then this, yeah, there you go. Now once this is done, you just slowly, slowly. So it's a fraction on top as well. So you make it a common fraction there, and try to substitute. But we come back. We are actually looking at this is dy dx, okay, dy dx. But we don't really need to express it, because what we actually need now is just to find the gradient value. So when x equals 2, we know that dy dx would just be 2 square plus 5, which is 9, minus 2 square, which is 4, minus 1 over 2 square plus 5, which is actually 9 and root 3, and this is 2 over 2 square plus 5. Okay, just key in calculator. This will be 9, so it's 3, so it's 6, minus this is 3, 1 over 3 times 2 over 9. Okay, so this will just be minus 2, 4 over 9. Is dy dx equals 4 over 9. Okay, so we don't really need to express it in the expression. Then once that this is a gradient of tangent, so gradient of normal will just be -1 over gradient of tangent and tangent. Okay, so this is -1 over 4 over 9, because it's 90 degrees there, and 90 degrees will mean that when you multiply it, it will just be m1 times m2, which is -1. So once this is done, we'll get -9 over 4, and after which what we're going to do is actually just going to use the point there, 2 and x. So y equals to mx plus c, and find the c by substituting y, -9 over 4, and x was 2, right? X was 2, y was 1. So 2 plus c. So c will just be 1 plus 9 over 2, which is actually just 1 plus 9 over 2 will be 11 over 12. So this is y equals to -9 over 4x plus 11 over 12. What do they want? They want us to express in that form. So I'm going to multiply with 4 and multiply with 4, because 4 is the most annoying one here. So this will be 4y goes to -9x after multiplying 4. The 11 over 12 multiplied by 4 will be 22. So this expression here could be expressed as, what do they want? 4y plus 9x equals 22. There you go. This is the answer. Yep. Any question or comments, please do let us know. Keep practicing, and yep, I'll see you in the next question, man.